My name is Oktay. This video is about the top 10 biggest moons by size and not mass. And this picture shows you a circumstellar disk. This is how planetary systems and stars are formed together. In this case, you have a central object, that's the star. You have leftover material. The planets are made of this leftover material, and you have unused material. These are, for example, in the solar system, the asteroid belt and the Kuiper belt. The systems of the big gas planets, together with their moons, are similar to this circumstellar disk, but at a smaller scale. In this case, you have the central giant planet. Again, you have leftover material. Leftover material is used for the moons, and you have unused material. In the case of giant planets, that's the rings. All four giant planets in the solar system have rings. This is number 10 moon, Oberon. It's a moon of Uranus. Its diameter is 1523 kilometers. And you can see the craters, big craters Hamlet and Othello. And in the northern polar region, there's a canyon called Momo Chasma. This is number 9. It's Saturn's moon Rhea. Its diameter is 1528 kilometers. It's a very bright moon, heavily cratered. It was discovered by Giovanni Domenico Cassini in 1672, and it has a thin oxygen and CO2 atmosphere. This is number 8. Titania. It's a moon of Uranus. Diameter is 1578 kilometers. It was discovered by William Herschel in 1787. And there's something special about the giant planet Uranus because its rotation axis is tilted towards the plane of the solar system. That's why this moon's poles are 42 years in darkness and another 42 years in sunlight, because the axis points towards the sun. This is number 7. It's the Neptune's moon, Triton. Its diameter is 2,707 kilometers. It was discovered by William Lassell in 1846, and this moon is known to have cryovolcanoes. These are volcanoes that bring dark material from the inner parts of the moon to the surface. This moon could have a subsurface ocean. Its orbit is retrograde. This means that it's slowly spiraling towards Neptune, and eventually this moon will explode and give Neptune a thick ring. This is number 6. That's Jupiter's moon Europa. Its diameter is 3,122 kilometers. It was discovered by Galileo Galilei in 1610. That was an important discovery because it's meant the end of the geocentric model of the universe. This was the first object that was clear that it's not orbiting the Earth but Jupiter. And the moons Io, Europa, and Ganymede are in a 4-to-1 orbital resonance. This means for four orbits of Io take the same time as 2 orbits of Europa and 1 orbit of Ganymede. This is exaggerated animation of the process that warms up the interior of the moon Europa. That's tidal heating. This moon experiences gravitational pull of Jupiter and other moons, and this kneading process heats the interior of the moon and gives it a subsurface ocean. That's a potential place for life because all criteria for life are met. You have an energy source, that's the tidal heating, you have liquid water, you have the minerals, and you have the basic molecules like CO2, carbon dioxide, and ammonia, NH3. The ice shield at the surface provides a nice protection against the cosmic radiation. That's why this moon is very interesting for future missions, like the JUICE mission, Jupiter Icy Moon Explorer, and the Europa Clipper spacecraft that are right now in the making. This is number 5. It's Earth's moon with a diameter of 3,475 kilometers. Earth's moon is heavy enough to stabilize the rotation axis of Earth. That's very important for the weather. The tidal forces of the moon spark life because they move all the water masses, and the molecules and the ions can nicely mix and react. Moon is tidally locked to Earth. However, the orbit is slightly eccentric. That's why you can see for 59% of the moon surface from the Earth. And another fact about the moon is it moves away from the Earth by 4 centimeters each year, which also means the rotation of Earth is slowing down. This is how the system Moon and Earth was formed. There was a collision of a Mars-sized planet, Theia, with Earth 4.5 billion years ago. 1969 was the moon landing of the Apollo 11 mission of Neil Armstrong, Buzz Aldrin, and Michael Collins. And the isotope analysis from the Apollo missions showed that Moon and the Earth's crust have a same isotope composition, and that supports this collision theory. And the collision took place at the right spot, not in the center that would have destroyed the Earth, and at the right angle. This is number 4. It's Jupiter's moon Io. Its diameter is 3,643 kilometers. It's the innermost Galilean moon. It experiences the strongest tidal heating of all the Galilean moons. That's why it has over 400 active volcanoes. The largest of which is Loki Patera with a diameter of 202 kilometers. And its yellow color comes from sulfur compounds and allotropes. Allotropes are different forms of the same chemical element. For example, one allotrope of chemical element sulfur is S8 with its Crohn structure. This is the third biggest moon, it's the moon Callisto of Jupiter. Its diameter is 4,821 kilometers. It's the outermost Galilean moon. It has no orbital resonance with the other moons, like all other moons, tidally locked. And you can see it's heavily cratered. And that's also a very interesting moon because it could have a subsurface ocean with potentially life. This is one big structure on Callisto. It's a multi-ring impact structure, Valhalla. This picture is from the Voyager 1. And the diameter of this structure is 3,800 kilometers. This is the second biggest moon in the solar system. It's Saturn's moon Titan. Diameter is 5,150 kilometers. It's a moon with a dense atmosphere, which contains 95% nitrogen, around 5% methane, traces of hydrogen, and solins, which are organic compounds that were formed by UV radiation. Its atmospheric pressure is 1.5 bar, and there are rivers and lakes of methane and ethane, and clouds and rain. And there's a cycle of methane like the cycle of water on Earth. These are two pictures from Titan's surface. On the left, that is a picture from Huygens robotic space probe, which landed on Titan in 2005. You can see that looks a bit like Mars, but it's a different. The difference is in the shape of the rocks. Mars has rocks there that have edges, and the rocks on Titan are like this one are much more rounded. That's because there's more erosion on Titan. And at the right you can see the North Polar lakes. These lakes are not filled with water, but methane and ethane. This is number 1, the biggest moon in the solar system. That's Jupiter's moon Ganymede. Its diameter is 5,268 kilometers. This moon is bigger than Mercury, but has less than half of Mercury's mass because Mercury has a massive metallic core. But Ganymede has also a metallic core and a own magnetic field. And it has a thin oxygen atmosphere with a pressure of about 1 microbar. This is what the interior of Ganymede could look like. There could be a subsurface ocean and a potential place for life. Now, thanks to the Kepler mission and other missions, we know that there are at least as many planets in the Milky Way as stars. And this will be very interesting to see what the maximum size of an exomoon, of a moon around another planet, exoplanet, is, and if these moons are habitable or not. And with future missions and telescopes, we will get closer and closer to the answers. This is Enceladus. It's just the 19th biggest moon in the solar system, but a very, very beautiful moon. Its diameter is just 504 kilometers. It was discovered in 1789 by William Herschel. This is like a mini version of the moon Europa. And this moon is also known for its subsurface ocean and its tiger stripes in the southern hemisphere. These are geysers that provide ice particles to the E-ring of Saturn. And this moon is also a potential place for life. And you have again the ice shield that protects the interior ocean from the cosmic radiation. And that was today's video about the 10 biggest moons in the solar system. Thank you for watching. Have a nice day. Bye-bye.